All right, 4.6, polynomial and rational inequalities, and this is going to be part 1. All right, so what we're going to do is we're going to solve each inequality algebraically. All right, so there's a few steps you need to take to make life easier on yourself. Part A, get 0 on one side of the inequality. Part B, find your zeros as if your inequality were set to 0. And you're going to set up some intervals with your zeros, and you're going to test each interval. All right, so for number 1, we have x plus 3 times x minus 1 quantity squared greater than 0. All right, so this is an inequality. We have the greater than symbol. And what we're going to do is we're going to just kind of go through this checklist here. So part A, we're going to get 0 on one side of the inequality. And notice that it's already done. The 0 is all by itself on the right-hand side. All right, so there's nothing to do for part A. Now part B, we're going to find our zeros as if our inequality were set to 0. In other words, if that inequality was actually equal to 0. All right, so basically we want x plus 3 to equal 0. And we would like x minus 1 to also equal 0. All right, so x equals negative 3 and x equals 1. All right, lastly, part C, we're going to set up intervals with your zeros, and we're going to test each interval. All right, so on this number line over to the right, I've got two numbers there, negative 3 and 1. I'm going to place those on the number line, and I'm going to get them in the right order. So the smaller number always goes on the left here. And we're going to basically check, get a checklist for our x plus 3 times x minus 1 quantity squared. I just want to make sure that the products are going to be greater than 0. All right, so we're going to start on the far left-hand side over here, and we're going to let x equal negative 4, right? And if x equals negative 4 and you put it in the first set of parentheses, it's going to give you a negative number. Put your negative 4 in the second set of parentheses. That's also going to give you a negative number, but we're going to square that. All right, so this is 3 negatives, basically, a negative times a negative times a negative, and that's going to be a negative value, all right, which is not bigger than 0, right? But I will put that right over here where it belongs on the graph, all right? So I'm going to get rid of that arrow. I'm going to put negative symbol right there on the left-hand side of the negative 3. Then I'm going to test a number between negative 3 and 1. We always like 0, right? Okay, so when I put 0 into the equation up above, or the inequality up above, I get a positive number, right, in the first set of parentheses, and a negative number in the second set of parentheses. That's squared, remember? So positive times a negative, that's going to give you a positive outcome. That's greater than 0. We like that. I'm going to put that plus right there. And last but not least, I'm going to try something on the right-hand side of the 1, like a 2. All right. That's over in this area over here. It's just something over there. All right, so when I put a 2 up above, I get a positive value in the first set of parentheses. Positive value. The second set of parentheses, we're squaring that, and we're also going to get a positive result. All right, so I'm going to put a plus on that number line down below where we're running that test. And then lastly, what we want are all the positive values in our interval. Okay, so our positive values are between the negative 3 and the positive 1. Right, so that looks like this right here. From negative 3 to positive 1. Now remember, at 1, that is 0. It equals 0. We don't want that. We want all the values above 0, or the positive value, which is above 0. And so we want everything to the right of 1. So we're going to make a union here, and we're going to go from 1 to infinity. Now, we're going to use parentheses on everything as a reminder, because this was just a greater than symbol, not a greater than or equal to symbol. All right, so this is your solution to this inequality. All of those values will satisfy the inequality. All right, let's move on to number 2.